The next operator we're going to look at is conjunction, or also known as AND. So let's say we have two propositions P and Q, and the conjunction of P and Q is denoted by this symbol P, and is written like this, P and Q. This is a proposition that says it's true when both P and Q are true and it's false otherwise. So that means if both P and Q are true, this proposition is true. If even one of them is false, this proposition is false. So let's take an example. Let's say P is a proposition that says X is a number between 6 and 10. Let's say Q is a proposition that says X is odd. So if I wanted to have P and Q, then I would need that X is odd and between 6 and 10. That would mean that X has to be either 7 or 9. The truth table for P and Q looks like this. So here we have two inputs, P and Q. If we have two inputs, each of them could be either true or false. That means we are going to have four possible rows in this truth table. The first row is for the case where both propositions are true. The second one is P is true, Q is false. Third one is the opposite, P is false, Q is true. Fourth one is both are false. The definition of conjunction said if both P and Q are true, then P and Q is going to be true. If even one of them is false, the conjunction is going to be false. That's why we have all these three entries as being false. Again, this is something I will mark as an important slide because this is something that will be important as we go along. Let's look at an example. So let's say here we have a proposition R. R says sky is blue and grass is green. So what is the truth value of R? The next operator that we are going to discuss is disjunction. In disjunction, again we have two inputs, P and Q. The disjunction of P and Q, we write it as P or Q, so it's basically inverted AND symbol. We write it as P or Q. And this is a proposition that is false if both P and Q are false, and it's true otherwise. So that means that P or Q is going to be true if either P is true or Q is true. If both are false, then P or Q is going to be false. One important thing to remember here is P or Q is true even if both P and Q are true. So in this sense, it is different than English OR, which is generally used as an exclusive OR rather than an inclusive OR, which this proposition is. So for example, in English, if I say you can have cake or cookies, that means you can have cake or cookies but not both. Whereas the OR operator in here is an inclusive OR. It means that you can have cake or cookies or you can have both. Now the reason we write the truth tables is to unambiguously define what each operator means. So what we saw on the previous slide was there was two ways of thinking about OR in English. It was either inclusive or exclusive. And to make sure that we are unambiguous about how we interpret a given operator, we have these truth tables. Once I have the truth table, I don't have to define whether it's inclusive, exclusive, anything. I just have to look at the truth table and decide what the value is. four operators. Once again, we have four rows. Uh, so the first row is for the case where both these propositions are true. The next one is when P is true, Q is false. The next one is P is false, Q is true. And finally, we have the row where both are false. So our definition was if both are false, P or Q is false. That's why we have false here. And even if one of them is true, the P or Q is true, and therefore we are going to have the true value here. We can also define exclusive OR. So here we have the operator P exclusive OR Q, or we often call it P XOR Q. And we write this as P XOR Q, where XOR is the symbol with a circle around a plus sign. So this is a proposition that says it's true when exactly one of P and Q is true and it's false otherwise. So let's look at the truth table. If both P and Q are true, then P XOR Q is false. If both are false, it is false. If exactly one of them is true, then P XOR Q is true. Once again, I will mark this slide to be important because this is something that would be important as we go along. So we can combine the different operators that we had. So for example, we can combine negation and disjunction. So here we have combined negation and disjunction by saying not P or Q. So first take a negation of P, then do a disjunction with Q. So here I have four rows because I have two variables. I need to worry about each one being true or false. So I'm going to have a total of four rows. And so if both P and Q are true, so let's see what's going to happen. Here Q is true, therefore the last operator that I have is OR. That means this is going to be true. Same thing over here. Q is true, so this operator not P or Q is going to be true. Here let's look at this one, the last row. Here P is false. This means that not P is true. If not P is true, then I have true or false, and that's going to give me the value true. Finally, what is left is this second row. Here P is true, so then that means not P is false. Q is also false, and that means that not P or Q is going to be false. What I want you to do here is I want you to review this slide. Make sure that you understand why this truth table is the way it is. And if there are any questions, we will discuss them in class. Once again, we have reached the slide called check before you go ahead. So here, suppose P is true, Q is false, R is true. I want you to find the truth value of all these propositions. If you have understood what the truth value is, go ahead. The answer is at the bottom of the slide. So if you have understood it and your answer matches with mine, wonderful. If not, be sure to check with me or the TA to be certain as to what is going on.